Hello, we are in algebra and trigonometry. We're in chapter 3.1, and we're looking at functions, function notation, domain and range, and what's the difference to start with between a relation, and what is a relation mathematically, and a function. So a relation is a set, so a group of ordered pairs, any ordered pairs that take the form of x comma y can be said to be a relation. So for instance, these ordered pairs that I have below on the slide, those would be considered a relation. 1, 3, 2, 5, 4, 6, 8, 10, 9, 12. That's certainly a set of ordered pairs, so we can call them a relation. The next thing I'd like to do is just talk to you about domain and range. So domain are the input values, or we can think of them as the x values. So a domain input values. And looking at this set of ordered pairs or relation, our domain, and we're going to use a curly bracket to identify the domain. We usually use a capital D for domain. Well, the domain is 1, 2, 4, 8, 9, because those are the x values. 1, 2, 4, 8, 9. Similarly, the range, which we'll use a capital R for, well, those are the y values. 3, 5, 6, 10, and 12. That's a working definition of domain and range. Domain, input values of a set of ordered pairs. Range, output values of a set of ordered pairs. So let's think in terms of the difference then between a relation and a function. Well, functions are a type of relation. So recall that relations are a set of ordered pairs, but a function does one more thing than a relation. A function assigns a single element in the range to each element in the domain. In other words, a function is a set of ordered pairs in which every input value has a unique and predictable output value. In other words, there are no x values that are repeated. So let's look at what that might, let's see what that might look like in a set of ordered pairs. Consider these following relations, again, sets of ordered pairs. Look at set A. We have for our domain 1, 3, 5, 12, 20. And for our range, when we're looking at set A, 1 maps to 2, 3 maps to 4, 5 maps to 6, 12 maps to 15, and 20 maps to 25. Therefore, if, for instance, I asked you to select 1 and asked you, hey, what's the output of that? You could unequivocally say 2. If I said, well, let's look at the input 3, what maps to 3? You could unequivocally say 4. If I said, hey, look, select 5, what maps to 5? You would tell me 6, and so on and so forth. No ambiguity, no this or that. Therefore, this set A of relations, are a function. Consider now set B. So looking at set B, for my domain, I have 1, and then I have 1 repeated, so I don't have to write that again in my brackets. 6, so we're looking at set B. 6, 12, and 22. Again, Those are the x values and the input values of set B. And now if I asked you, go ahead and map the domain to the range. And in the range we have a 2 and a 4, a 7, a 15, and a 26. So I said, hey, if I asked you, what does 1 map to? You would look at these first 2 ordered pairs and you'd say, well, the domain 1 maps to either 2 or 4. As soon as you say this particular set, this particular group of relations is not a function. In other words, this x value does not have a predictable, a single output value. Once we say it could be 2, it could be 4, no longer a function. All right, so if you would look at this next slide, determine which, if any, of the relations below are functions and justify our reasoning, I want you to know that I made you a resource sheet and I uploaded it into WAMAP, and it calls itself, I've called it resource sheet functions. And these first 4 questions you can find on that resource sheet. So let's look at the input values here. In other words, the domain. I'm going to make this a little bit larger. Well, 0 maps to 0, 1 maps to 3, 2 maps to 6, 3 maps to 9, 4 maps to 12, 5 maps to 15. Very clear, there's no ambiguity. Each input maps to a unique and predictable output. Therefore, we can say of set 1, yes, this is a function. Okay, let's look at set 2. The input value 2 maps to 4. The input value 2 maps to 6. The input value 2 maps to 8, 2 to 10, 2 to 12, 2 to 14. This is completely ambiguous. We cannot clearly say that 2 maps to any one singular value. Therefore, we can with certainty say that 2 is not a function. All right, let's consider the third set of the relation in number 3. Is it a function? So we have a 0 maps to 5, a 1 maps to 5, a 2 maps to 5, a 3 maps to 5, a 4 maps to 5, a 5 maps to 5, and a 6 maps to 5. Hey, look, each one of those input values is clearly mapped to a predictable output value. Granted, it is the same output value, but the definition of a function is, does the input value map to a predictable output value? And the answer there is yes. So in this case, set 3 is a function. It does qualify. Set 4 I wrote purposefully because many times people think a function has to have a rule that they can see or a rule that's very clearly prescribed to get from an input to an output value. But that's not true. Again, the definition of a function is that the input value maps to a clear and predictable output value. So I was very random when I wrote these ordered pairs. I had no intention of making a rule that was predictable here. However, I can tell you that 8 maps to 12, one input value. -2 maps to 119, pardon me, one output value. -3 maps to -3, so very clearly singular input, predictable. 1/2 maps to 0, -118 maps to 7, 29 maps to -29, 1/4 maps to 5/9. So in other words, if I said to you, hey, what's -118 mapped to? You could say, oh, the output there is 7, no ambiguity. And so you could say that of each of these 1, 2, 3, 4, 5, 6, 7 ordered pairs. Therefore, each input maps to a very clear and predictable output value. Therefore, this is a function. All right, so here's the formal definition of a function. and you can find this in your textbook. In fact, this is a copy paste of that image. A function is a relation in which each possible input value leads exactly to one output value. You can say that the output is a function of the input. Input value, by means of a review, we'll refer to as the domain, while the output values we'll refer to as the range. All right, we've been talking about function mapping, looking at functions as ordered pairs. So now let's look at functions in terms of, let's say that we did have a set mapped to another set, and they're displayed in the way that I've displayed the next grouping, 1 through 4. So looking at number 1, the domain are to the left of the left ellipse, and the range are the right ellipse. And just notice that, look, if I start with 1, I clearly am mapped to 7. I don't see any other alternatives for that. Get thinner highlighter here. Input 3 maps to 2. Input 5, again, clearly maps to 2. That's just fine. Each of these can go to the same output value as long as if I say, hey, what's 3 mapped to? You say 2. What's 5 mapped to? You say 2, and there's no or. That's a function. 7 maps also to 2, and 9 maps also to 2. Input values lead to exactly one output value, predictable. So yes, number 1 is a function. Let's look at number 2. And the technical term for this is actually function mapping. So I look at 0. 0 maps to 3. That's good. I look at 2. 2 maps to 8. That's good. I look at 3. 3 maps to 6. That's fine so far. It's looking good. It's looking positive in terms of, is it a function? 5 maps to 3. Still good. 5 maps to a singular output. But I'm perceiving there's a problem here. It looks like when we focus on 9, the input 9 maps to 3, or it maps to the output 8. And it's that little word or that lets us know that this is not a function, because the input 9 maps to 2 possible outputs. Therefore, number 2 is not a function. All right. Let's look at number 3, and I'm wondering if you already see it. As soon as you look at the input 0, 0 maps to 1, and or 0 maps to 6. So number 3 is disqualified, not a function. Let's look at number 4. Quick scan of number 4 is looking like it's a good possibility. 0 maps to 1 unique output. 2 maps to 6. 3 maps to 5. 8 maps to 2 in our last set of ordered pairs. 9 maps to 2. What do you say? Is this a function or not? I think I hear you, and you're right. Yes, this, number 4, is a function. And finally, for purposes of this video, let's look at, are we able to read a function from a graph? So in other words, I have a set of ordered pairs here that do constitute a function, and this graph is, of course, a parabola, quadratic. So if I were going to ask you to give me the range, I've given you the domain, if I were going to give you the range, I'm asking you to give me the range, you would look at this and say, all right, it looks like when x is 0, then my domain or my y value is 5. When x is 1, then my domain or y value